Okay, let's try to do problem 16. Three forces act on an object, but it has no acceleration. The first force has a magnitude of 75 newtons and is directed due south. The second has a magnitude of 48 newtons and points at an angle of 40 degrees west of south. What is the magnitude and direction relative to due east of the third force? Okay, so I've already drawn a picture here, and if you want to pause it, you can. The first force, they said, was 75 newtons south. So I drew a box here, that's our object, and then I put north is up here, west here, south here, east here. So first force went directly south at 75 newtons. The other force was at 48 newtons, and it came in at an angle 40 degrees west of south. So here's my south line. It's parallel with this 75 newtons. This is my y. So I said it's 40 degrees west, so it's going west from the south. Okay, so that's how you get this picture here. The magnitude is 48 newtons, and it's coming in. So it's asking, okay, what's this third force, right? What's this third force? Well, I kind of already have it drawn here because I know it's going to go in the opposite direction of the forces, of the force combined, or the forces combined of F1 and F2. It's going to go in the opposite direction of these two. Because, we go back up to the problem, this object has no acceleration, but it has three forces acting on it. So F1 and F2 act on it. It would normally go, if it was just F1 and F2, the object would go this way, right? It would go shoom, like that. But we have this third force here that we don't know its value, but we know it's there. It's going to offset F1 and F2 and make sure that this object's not going to move. So to find F3, we're going to have to add up. We're going to have to, we can write out a little equation here. F3 is going to equal F1 and F2 combined. But we can't just take 75 plus 48. We're going to have to break these down into x's and y's. We're going to have to find the x and y value of F1 and the x and y components of F2. Sorry, we need to find their components, and then we're going to add their x's, we're going to add their y's, and hopefully that'll help us find F3. F3's magnitude is going to equal these two, but it's going to go in the opposite direction of their resulting forces combined. So let's go down and let's start plugging in here. So to find F1 and the y, it's all in the y. It's going directly south, so it's 75 newtons south. F2, on the other hand, is coming in at this angle, so I redrew it over here, and you can pause the video and redraw it. It's coming in on our object. Here's our object at 48 with 48 newtons of force, and at an angle of 40 degrees west. So this is my west over here of south, and this is south down here. So its y component's going that way. Its x component is going that way. Okay, so we have to break it down. To do that, we're going to use our trig functions because we have the hypotenuse and we have theta. So let's use the trig. To find our x component, we're going to go, it's opposite of our angle, so it's 48, our hypotenuse, times sine of theta, which is 40. And I don't have that calculated, sorry. I brought up Google here, it's calculator. So 48, and I'm in degrees, 48 times sine of 40. What does that equal? That gives me 38.5. So I'm going to copy that. And it's here's our x. So I'm going to paste that in there. And let's label this. This is a force. These are all forces, so it's newtons, and it's going west, right? So we'll put west. Okay. Now we just got to find the y component. We're going to use cosine because it's adjacent to the angle. So the hypotenuse times cosine times 40 I'm going to go back to my calculator, and I'm going to go, I'm still in degrees. Okay, so 48 times cosine 40 in parentheses equals 36.77. Now, we should have 3 sig figs, 2 or 3 sig figs at the end. I'm just carrying that extra unit so we don't lose any information. Paste it in here. Drag it down. Okay. And let's label this. This is newtons because it's force. And it's going down, right? South, because the overall is going at an angle to the southwest. So the y component's going south. Okay. So this is just force 2. This is all the components of force 2. We want to add, we set up here, we're wanting to add F1 and F2 together to get our F3, to find the magnitude of F3. So Fy of the total of F1 and F2 combined. So F1 had 75 newtons, and that was to the south. So I'm going to say to the south is positive right now. And we're going to add that to our F2, its y component, and that's 36.77 newtons, and that's also going to the south. So I'm going to say that's positive as well. So we're just going to add these. They're going in the same direction. They're both going like this, right? So we can find that value. I'll just use this calculator. 75 plus 36.77 equals 111.77. That's a nice number there. Let me draw that in red. 0.77, and this is newtons. That's south. Okay. The x total will be just from our F2 because the F1 was all y. So our F2 x component was 30.85 newtons west. Okay, so that's like going this way. All right, I want to find the result of F1 and F2, and that's like this, right? I want to find that magnitude. This is a 90 degree right here. We know theta right here is 40 degree. Sorry, we don't know that for sure. Sorry, let me back up. Okay, so I want to find this, but I'm wanting to find this force because, again, back up here, we said F3 is going to equal my F1 and F2 because it's going to offset it. This box is not moving. It's just going to offset it. So it's not going to go in the same direction as these two added together. It's going to go in the opposite direction. So I'm going to go back down to that triangle. And instead of finding this arrow, I want to find, now watch, this is fancy here, I want to find this. That's my F3. So it's going to be the same in magnitude, it's just going to have a different angle. I want to find this angle right here. I want to find that theta. I want to find this hypotenuse. And again, to recap, this was my F1, this was my F2 in the Y, and this was my F2 in the X. So that's going to help me find my F3. Okay, so let's plug in our numbers here. This side over here was, I'm going to use this number, 111.77 newtons south. And this side down here was 30.85 newtons. Okay, so, and that's going west, right? And this was going south. But again, I want to find the opposite, so I could say, here's what I could say. Okay, this F3 is going this way, so it's going in the opposite direction. So I'm going to make my you could say your components are going in the opposite direction. But I mean, if that's confusing, we don't have to do that. Let's move this. I'll move this down. Is that all going to move with me? Nope. It's just all going to rotate with me. There we go. Okay. I'm running out of room. Sorry. Okay, so now that you know all these sides, we know that this is 111.7, you know this is 30.85 newtons west, we can simply use to find F3, we're just going to use the 111.77 newtons squared plus 30.85 newtons squared. Find the square root of that, right? Pythagorean theorem. This is C, this is A, this is B. And then to find theta, theta is going to be, let me see here, it's going to be, I want to know, I have the opposite and I have the adjacent, so we can use tangent -1 out of my opposite, which is 111.77 over 30.85. Alright, so that will get you the answers. I'm not going to go ahead and work those out. I think you can do it. I'm running out of time. So find F3, find theta. Remember, this is relative to east, so this angle is going to be so much north of east because it's going back in the east direction. The result of F1 and F2 is going in the southwest direction, but F3 is going to offset that, so it's going into the northeast direction. So it's going to go so many degrees north of east. That's how they want you to word the number, and it's going to be so much magnitude at so many degrees north of east. Okay, that's problem 16.